Logarithms. Let's check out the laws of logarithms. What are they? How many of this number do we multiply to get that number using powers? Why? Because they have a relationship with exponential functions. Interesting fact. Kangaroos can hop around quickly on 2 legs or walk around slowly on all 4. Now, let's take a look at all the rules that we're going to be discussing in today's video. Let's go ahead and start with the base rule. We have log of a to base a is equal to 1. Let's go ahead and put some numbers in to see what we're dealing with. And now we have log of 5 to base 5 is equal to 1. Let's go ahead and write down the number inside the parentheses and set that equal to, well, we're going to set it equal to the base raised to the answer. And in this case, it is going to be 5 raised to the power of 1. Let's go ahead and put that in. Now we have 5 is equal to 5 to the power of 1. And that is true. Therefore, we can say that the log of 5 to base 5 is equal to 1. And that means if the log of any positive real number and the base are the same, then we can say the answer is 1. And that's the base rule. Let's move on to the next rule, and that is the log of 1 rule, which states the log of 1 to base a is equal to 0. Let's go ahead and change a to a number, and now we have the log of 1 to base 3 is equal to 0. Now let's see why this is the case by writing down the number 1 and setting that equal to the base raised to the answer. And in this case, that would be 3 raised to the power of 0. And now we have 1 is equal to 3 to the power of 0. And that is true because anything to the power of 0 is 1. Therefore, we can say that the log of 1 to base 3 is equal to 0. And that means the log of 1 to any positive real number base will give you the result of 0. Let's go ahead and take a look at the product rule, which states the log of x times y to base a is equal to the log of x to base a plus the log of y to base a. Let's go ahead and put some numbers in to see what we're dealing with. And now we have the log of 4 times 5 to base 2. And now we're going to use that first number 4 and write down the log of 4 to base 2. And the most important part right now is that we have the plus, and that is because we're multiplying inside our original log. And now we're going to use that second number 5 and write down the log of 5 to base 2. And that means we can rewrite the original log as a sum of 2 or more numbers using the product rule. Now let's move on to the quotient rule, which states the log of x divided by y to base a is equal to the log of x to base a minus the log of y to base a. Now let's add some numbers to see what we're dealing with. Now we have log of 2 sevenths to base 3. Let's take a look at the numerator of the number on top 2 and write down log of 2 to base 3. And the most important part right now is that minus sign. Since we're dealing with the quotient rule, we need to have a minus sign, and everything in the denominator is going to be minus something. And so let's take a look at the denominator or the number on bottom 7 and write down log of 7 to base 3. And that means we can rewrite the original log as a difference of 2 or more numbers using the quotient rule. Let's go ahead and take a look at the power rule, which states the log of x to the power of n to base a is equal to n times the log of x to base a. Let's put some numbers in to see what we're dealing with. And now we have log of 4 to the power of 5 to base 2. Let's take a look at the power or exponent, and in this case that would be 5, and that is the first thing that we have to write down. And the second thing we write down is what we haven't used so far, and that would be the log of 4 to base 2. And that means every time you have a positive real number raised to the power of something, you can put that power or exponent out in front of the log using the power rule. Now let's take a look at the reciprocal rule, which states the log of 1 over x to base a is equal to the negative of the log of x to base a. Now let's go ahead and put some numbers in to see what we're dealing with. And now we have the log of 1/9 to base 4. Now we're going to write down the negative and the multiplication inverse of 1/9, which is 9. And now we have the log of 1/9 to base 4 is equal to the negative of the log of 9 to base 4. One reason why this is the case is that we can rewrite 1/9 as 9 to the power of negative 1 using the rules of exponents. And now we have the log of 9 to the power of negative 1 to base 4. That looks like the power rule, so let's go ahead and move that power or exponent, in this case negative 1, out in front of the log, and now we have negative log of 9 to base 4. And that means every time you have a positive real number in the denominator, you can go ahead and flip it and put that number in the numerator and put a negative out in front of the log using the reciprocal rule. Let's take a look at the change of base rule, which states log of x to base a is equal to log of x to base b over log of a to base b, which is also equal to 1 over log of a to base x. Now let's just focus on the left side and the center. Let's add some numbers to see what we're dealing with. And now we have log of 6 to base 5. Let's write down what that is equal to. And now we have log of 6 to base 8 over log of 5 to base 8. So the 6 stayed in the same spot and now is in the numerator. And the old base 5 is in the same spot as the 6 but in the denominator. And our new base is 8, or any positive real number. Now let's take a look at the other way of changing the base. Let's get rid of the center so we can go ahead and focus on the left side and the right side. Let's add some numbers to see what we're dealing with. And now we have the log of 6 to base 5. And let's write down what that is equal to. And we have 1 over the log of 5 to base 6. So those are the two ways to change the base. And that means we can rewrite the original log with different bases using the change of base rule. Let's re-show you all the laws so you don't have to rewind the video to find the previous one. Now it is your turn, so go ahead and pause the video so you can answer this question, and I will show you the results in 3, 2, and 1. If you got them correct, congratulations. If not, there is always tomorrow.